Hello, in today's lab, I will be configuring and explaining ASA. As you can see in the topology, our ASA is the Edge CPE security device that connects our internal company network and the DMZ to the ISP, while providing NAT and DHCP services to the inside host. As you can see here, we are connected to the ISP. Router 1 is managed by the ISP. Router 2 represents an intermediate internet router, and router 3 is representing an ISP that is connecting our remote location office. The ASA will be configured for management by an administrator on the internal network and by the remote office. Also, Layer 3 VLAN interfaces provide access to the three areas: the inside, outside, and the DMZ. We will be provided our public IP address by the ISP, which is in today's lab 209.165.200.224/29, which we will use for NAT on the ASA. I will introduce you first to the ASA device. Let us first determine the version and the interfaces and the license on this device. So on the ASA, I will simply type this command, which is show version, and I will expand it to show you. Take your time studying it when you run this command. As you can see here, it's showing us the device's version, and here is the image and where it's located in disk 0. And also it's showing us, if I scroll down, that this device has a base license. And when you run this command, just study it slowly and carefully. Anything you have difficulty understanding, just Google it and you will get the answer. Next, I will enter the privileged exec mode by typing enable, EN or enable, enter. No password yet, just hit enter. Now, from here I will run this command, show file system, enter. Here is showing us the size of the file system and also how much we have a free space on the disk. Next, I will use either command show flash or show flash, or also show disk. And as you can see here, it's showing us the length and the path in the bin file. Now I will start configuring the ASA device. From the global configuration mode configure terminal, I will enter the host name for our device here for today of ASA-5505 and then hit enter. I will configure the domain name of academy.com. Simply type the command domain name academy.com. Next, I will configure the enable password of Cisco. Enable password of Cisco. Next, I will configure VLAN 1. VLAN 1 will be inside and VLAN 2 for outside, and I will configure VLAN 3 here on the DMZ later during this lab. I will configure a logical VLAN 1 interface for the inside network with the IP address of 192.168.1.1/24, and I will set the security level up to 100. So back to the ASA. From the global configuration mode, I will enter VLAN 1, and the name of the interface is inside. Hit enter, and this is with the IP address of 192.168.1.1/24. for subnet mask, and the security level for VLAN 1 of 100. Next, I will create VLAN 2 interface for the outside network with the IP address of 209.165.200.224/29, and I will set the security level to 0. So on the ASA, for the interface of VLAN 2, and the name of the interface is outside, and this is with the IP address of 209.165.200.226 and 255.255.248/29, and then hit enter. The security level for the outside network of 0. Next, I will verify the configuration and run the show command. Here, you can run the show command from anywhere. This command is different from the iOS command, show IP interface brief. Also, most of ASA show commands can be issued from within any configuration mode prompt without the do command. So here I will type show interface IP brief. Here showing us for VLAN 1 what we configured, and for VLAN 2 the IP addresses and the status is up and up. I will enter another show command, show IP address. Here is showing us for the system IP addresses for VLAN 1 and VLAN 2, for the name is inside and outside IP addresses subnet mask, and also another show command which is show switch VLAN, showing us the two VLANs which we named inside outside, the status and the ports. We should be able to ping from PC2 to the ASA inside interface on the 192.168.1.1. So I'll shrink this and go to PC2. PC2 is configured with this IP address, but from here I'll ping 192.168.1.1, hit enter, and it was successful. Also from PC2, I'll try to ping VLAN 2, which is the outside interface on 209.165.200.226. I'll try to ping this interface here from PC2, ping 209.165.200.226. This should fail. I will not just wait for it. I will configure routing, NAT, and inspection policy using command line interface on the ASA. Now I will start by configuring a default static route on the ASA outside interface to enable the ASA to reach external networks, and on router 1 on the gigabit Ethernet 00 IP address 209.165.200.225 as the gateway of last resort. So go back to our guy here. From the global configuration mode, simply type this command. We want to route for outside to any network with this IP address, and our gateway of last resort should be on this interface on 209.165.200.225, and then hit enter. So what we did, we want to route to outside to any network, and this is the gateway of last resort on this interface from the ASA device. Now I will verify by running this show command, show run, show route. As you can see here, this is our default static route. Now I will, on the ASA, verify if we can ping router 1 on the interface of serial 000 on this interface here. So I'll run this command ping 10.1.1.1 and this should be successful. And it is run it again, upper arrow on the keyboard and then hit enter. Next, I will configure address translation using PAT. PAT stands for Port Address Translation and Network Objects. I will create network object, name it inside-net, and assign attributes to it using the subnet and NAT commands. Now, what is object network in ASA? A network object can contain a host name, a network IP address, a range of IP addresses, a fully qualified domain name, FQDN, or a subnet address expressed in CIDR notation. Network objects and network groups are used in access rules, network policies, and NAT rules. This was a definition. Another one. Network objects are defined segments of your network that you can reuse throughout multiple responses. Use the network objects feature to centralize data entry so that you only need to change the network object instead of each instance of the data. Now back to our ASA device here. From the global configuration mode, object, network, as I said, we'll name it inside-net. Now, our subnet, the internal subnet of 192.168.1.0/24 subnet mask. And we want to NAT from inside to outside dynamically on the interface. Enter. And I'll end it here. Now, the ASA splits the configuration into the object portion, which defines, I'll run this here, and expand this a little bit, as you can see. The ASA splits the configuration into the object portion, which defines the network to be translated, and the actual NAT command parameters. They will appear in two different places, as you can see here. And when I run the show run command, this is what we have. This is for the subnet and for the NAT. Now, I will try to ping, I shrink this. I'll try to ping the interface on gig 00 on router 1. On PC2, ping 209.165.200.225, and this should fail. And you will know later why this should fail. We send the ping, but are we, because this is our security device. Back to the ASA, I'll issue the command show NAT on the ASA, as you can see, to translate and untranslated hits. We will notice that of the pings from PC2, 4 were translated, these 3 hits here were not. The outgoing pings, echoes, were translated because they and sent to the destination, but the returning echoes replies were blocked by the firewall policy. Now, I will configure the default inspection policy to allow Icmp. I will modify the default MPF, Application Inspection Global Service Policy. Now, what is inspection in ASA? When many people think of protocol inspection, they think of a process that reads the data of a packet and inspects it for some amount of wrongdoing. But in reality, the packet inspection feature of the Adaptive Security Appliance, ASA, is typically used to help make the protocol work better. Internet Protocol Inspection also enables the ASA administrator to control traffic based on a number of different parameters that exist within the Internet traffic, including the information contained within the data portion of the traffic. You heard me saying MPF. What is MPF? It's Modular Policy Framework. ASA Firewall Networking Modular Policy Framework configuration defines set of rules for applying firewall features, such as traffic inspection, QoS, quality of service, etc., to the traffic transiting the firewall. Now, for application layer inspection and other advanced options, we have Cisco and PF available on the ASA device. On Packet Tracer, ASA device does not have MPF policy map by default, so I will modify it, and then we can create a default policy map that will perform the inspection on inside to outside traffic. And when we configure it correctly, only the traffic initiated from the inside is allowed back into outside interface. I will add Icmp to the inspection list, as you will see in a moment. Now I will create a class map, policy map, and service policy, and then add inspection of Icmp traffic to the policy map list as follows. But first, what is a class map? A class map is an entity that you can create in a router that classifies network traffic. The class map will classify network traffic based on various match criteria configured within a class map. In other words, it defines traffic classes. And what is service policy, Cisco? Service policy using modular policy framework provides a consistent and flexible way to configure ASA features. For example, you can use a service policy to create timeout configuration that is specific to a particular TCP application, as opposed to one that applies to all TCP applications. Now, let's dive back and continue our configuration. So here on our guide, the ASA from the global configuration mode, class, map, inspection underscore default, enter. And we want it to match the default inspection traffic, and then hit enter. If a packet matches multiple different match or class commands, then the order in which the ASA applies the actions is determined by internal ASA rules and not by the order they are added to the inspection policy map. I'll exit from here. Policy map, call it global policy, enter. The class inspection default, enter. And what do we want to inspect here? We want to inspect the Icmp. I'll exit, but as for the service policy, global policy, and we want this either on interface or global. We choose global and then hit enter. Now let's verify what we did. From PC2, I will ping router 1. From here, I will ping router 1 on gigabit Ethernet 00, the IP address of 209.165.200.225 on PC2. I'll run the command ping 209.165.200.225, and this should be successful because Icmp traffic is now being inspected and legitimate return traffic is being allowed and inspected. The ASA can provide a DHCP server to DHCP client attached to ASA interfaces. The DHCP server provides network configuration parameters directly to DHCP client. I will configure DHCP, AAA, and SSH. I will configure the ASA as DHCP server. I will configure a DHCP address pool first here and enable it on the ASA. So back to the ASA, simply type this command. Now for the pool, DHCP address, want to start from 192.168.1.52, which is this dash represent, to 192.168.1.36, and this is for the inside, the host in the inside network. Now I will enable it within the ASA to listen to the DHCP client request on the enable interface for the inside. Simply type DHCP, enable it for the inside. And in our example, we have only one host. Because I'm done with the DHCP configuration, I will change PC2 from static IP address to DHCP client and make sure that it receives the IP configuration from DHCP. So on PC2, I'll go to the IP configuration, and here, as you can see, I configured it statically. I'll click on the radio button here to see if it will receive an IP address, and sure enough, it did with 192.168.1.5. Now, I will configure a AAA to use a local database for authentication. Now, what is AAA? It stands for Authentication, Authorization, and Accounting. AAA is a mechanism that is used to tell the firewall appliance who the user is, this is authentication, what actions the user is authorized to perform on the network, this is our authorization, and what the user did on the network after connecting, and this is our third A, which stands for accounting. Now, I will define a local user. I'll give this user a name of admin1 with password of Cisco. So back to our guy here on the ASA. From the global configuration mode, I want our user, I'll name him admin1 with the password of Cisco. Enter. Now I will configure a AAA to use the local ASA database for SSH user authentication. For AAA authentication for SSH console to use local. This is how to read it, and hit enter. Now, login is used on VTY and console and means that the password that is user for its authentication is configured under VTY and console as well. Be configured to accept connections from a single host or range of hosts on the inside or outside network. In our example, I will configure access to outside devices to be able to connect to the ASA through SSH. Also, SSH can be used to access the ASA from the inside net. Now, what does RSA stand for? The acronym stands for Ravist or Rivest, Shamir, and Adelman, the inventors of the technique. The RSA algorithm is based on the fact that there is no efficient way to factor very large numbers. Deducting an RSA key, therefore, requires an amount of computer processing power. And what is an RSA key? It's a private key based on RSA algorithm. It's a part of the public key infrastructure that is generally used in case of SSL certificates. A public key infrastructure assumes asymmetric encryption, where two types of keys are used, private key and public key. I will generate RSA key pair, which is required to support SSH connections because the ASA device has RSA keys already in public. I will simply enter no when prompted to replace them. So back to the ASA. From the global configuration mode, the command goes like this: crypto key generate RSA modulus, and the size of this key 1024 bit, and hit enter. Now, as I said, we simply hit no because it's already in place. Now, I will configure the ASA to allow SSH connections from any host on the inside network, on this network 192.168.1.1/24, and also from our remote office here, host, just one host at the branch office, and this host with the IP address of 172.16.3.3. I will set the SSH timeout to 10 minutes. So back to the ASA, from the global configuration mode, we want to allow SSH to this network of 192.168.1.0/24 subnet mask, and this is inside. And also allow SSH from this guy, this host on 172.16.3, just one host, and /32 subnet mask. And this is on the outside. And hit enter. And as I said, our SSH timeout just for 10 minutes. Now I will verify by establishing an SSH session from PC3 to the ASA. From here, desktop command prompt, type the command SSH and establish a link. This is a link, and use this credential of admin1 to 209.165.200.226, and then hit enter, and the password of admin of Cisco, and we were able to. Now we are on the ASA device. I'll exit. Now I will also establish an SSH session from PC2. So here is our PC2. Close this from the command prompt. Establish an SSH session. A link. This is L. Use the credentials of admin1. Access the SSH on this interface of 192.168.1.1. Hit enter, and the password of Cisco. And it was successful. Now I will configure DMZ, static NAT, and access control list. Now on router 1 and on. Now I will configure the DMZ, static NAT, and access control list. I will use a public IP address of 209.165.200.227 and static NAT to provide address translation access to the server. What is DMZ on Cisco? It's an interface that sits between a trusted network segment, which is our company's network, or the inside network in this example, and an untrusted network segment, which is the internet, providing physical isolation between the two networks enforced by a series of connectivity rules within the firewall. Static NAT on ASA, network address translation, which is NAT, is a process in which a private IP address is translated to a public IP address. This hides the IP address of the original source device from the outside network. I will configure DMZ, the VLAN 3, which is where the public access web server resides. I will assign the IP address of 192.168.2.1/24 and name it DMZ, and assign a security level of 70 because the server does not need to initiate communication with the inside users. And I will disable forwarding to interface VLAN 1. So back to our ASA. From the global configuration mode, I will enter VLAN 3. And this is with the IP address of 192.168.2.1/24 subnet mask. And as I said, no forward on interface of VLAN 1. Now, what does this mean? This command simply prevents any traffic originating from the DMZ from entering the inside network. Once again, this command prevents any traffic originating from here, from the DMZ, from entering the inside network. So back to the ASA. Now the name of the interface, DMZ, enter. And this is with security level, as I said, of 7. Now I will assign physical interface on Ethernet 02 on the ASA to DMZ VLAN 3 and then enable the interface. Now on the interface of E02, switch port access VLAN 3. Enter. Now I will verify my configuration by running these show commands. So from anywhere, as I said, you don't need to type do show command, just type show interface IP brief. As you can see, oh, sorry about that, back here. Now it's showing us interface IP brief. And another command of show IP address is showing us the 3 VLANs with the names and with the IP addresses and the subnet masks. And another show command shows switch VLAN. Here it will show us our 3 VLANs, their numbers and their names and the status and the ports. Next, I will configure a static NAT to the DMZ server using a network object. I will configure a network object named DMZ-server and assign it to the static IP address of the DMZ server of 192.168.2.3. And while in the object definition mode, I will use the NAT command to specify that this object is used to translate a DMZ address to an outside address using static NAT. And I will specify a public translated address of 209.165.200.227. So back to the ASA. Here, the object of the network, as I said, we'll name it DMZ-server, SVR. Enter. And this is for the host, which is our server of 192.168.2.3. And then hit enter. Now, what do we want to NAT? We want to NAT from the DMZ to outside statically. Use this static IP address of 209.165.200.227. Hit enter. And then I'll exit from here. Next, I will configure an access control list to allow access to the DMZ server from the internet. I will configure a named access list. I'll name it outside-DMZ, all caps, that this will permit the TCP protocol on port 80 from any external host to the internal IP address of the DMZ server. Then I will apply the access list to the ASA outside interface in the N direction because we will be accessing it from here, entering the ASA on this interface in the N direction. So on the ASA device, configure terminal access list, as I said, and name it outside DMZ. We want to permit Icmp from any to our server, our host on 192.168.2.3. This is for the Icmp. Hit enter. Another access list also the same name, outside dash DMZ. We want to permit TCP from any to our host, which is the server on 192.168.2.3. Now, the access group, which is the same name, outside dash DMZ, we want it in the interface, in the N direction on the interface from outside, and hit enter. Now, unlike iOS access control lists, the ASA access control list permits statements but must permit access to the internal private DMZ address. External hosts access the DMZ server using its public static NAT address. The ASA translates it to the internal host IP address, then applies the access control list. Now let us check connectivity. So here on PC3, I will ping the public IP address of the DMZ, ping 209.165.200.227, and it was successful. I'll run it again. Now, it will not be able to reach it with its private IP address on 192.168.2.3 because this is how we configure the access control list. And I will just cancel it with the control key and the C letter on your keyboard. Now, on the web browser on PC3, click on the web browser here and enter the public IP address of 209.165.200.227, and we were successful. Now on PC2, here, I will ping this interface here. This is PC2. I will ping 10.1.1.1, and we were successful. And also, I'll try to ping the interface on router 1 of gig 00 of 209.165.200.225, and also we were successful. And on your own here, run these show commands: show NAT, show run, show interface IP brief, show switch VLAN, show IP address. Just study these commands, run them on your own and study them. And that's it for today's video. I hope you liked or you learned something from this video. And I kind of forgot the name of one of the guys here asked me that he had difficulty with a previous lab, how to ping, and I hope this explained it. And please, if you like this video, share this video on your Facebook page. And if you want to know more or to practice more videos I have on my Facebook page, just visit that page and I have all the videos listed there. And if you have any comments, questions, or suggestions, please write me and I'll answer you back. Thank you so much for watching, and I will see you soon in my next video. Wishing you a nice